The selection of the HPLC detector is based on the analyte chemistry, and the selection of the HPLC detector or choice of the detector directly has impact onto the sensitivity, selectivity and accuracy of the method. HPLC detectors work on different principles based on the properties of the analyte. The properties are UV absorbance, fluorescence potential, volatility, electroactivity, and the refractive index. Based on the analyte properties, we need to select the proper HPLC detector, and this HPLC detector should ensure the analysis as robust, reliable, accurate, and the sensitive. UV visible detector or UV detector, it is used for majority of the organic analysis, and it measures the analyte absorption at a specific UV wavelength. For this we need to derive or we need to have the lambda max. Key points regarding the UV detector: most used detector, it is a widely used. It has good sensitivity for chromophore compounds, that means the compounds which have UV activity, and works best when the compound absorbs UV between 190 to 400 nanometer range or 200 to 400 nanometer range. This detector cannot be suitable or is not suitable for the analysis without UV chromophores. So if your compound is not having chromophore, then you cannot use this. Then PDA detector. It is a photodiode array detector, and it is ideal for the organic analytes with chromophores. So if your analytes have the chromophores, then you can go for this detector. Then use for the compounds with overlapping peaks. Advantages of PDA detector are that it can scan multiple wavelengths simultaneously, enables the spectral purity, co-illusion assessment can be done, and the peak identification can be done. It is useful for force degradation and method development. Why you need to choose PDA detector? The reason is superior versatility compared to single wavelength UV. So PDA detector can give you the advantage of scanning of the multiple wavelength simultaneously. Then FLD detector, fluorescence detector. It is ideal for aromatic compounds, highly conjugated systems, compounds with strong pi-pi transitions, and acyclic carbonyl structures. Benefits of FLD detectors: extremely high sensitivity, much higher than the UV, and selective detection. So it gives you lower background noise. Applications: for vitamins, aflatoxins, biomolecules, you can go for the use of fluorescence detector. Then RID, it is refractive index detector. It is ideal for the sugars, polymers, alcohols, compounds with no UV absorbance. There are some compounds which doesn't show UV absorbance. For that, RID can be used. Advantages are that the universal detector responds to almost all compounds, simple, non-selective. Limitations are it cannot be used with gradient illusion, lower sensitivity compared to UV and PDA. Then ECD detector, electrochemical detector, ideal for the redox active biomolecules or molecules, multivitamins, catecholamines, pharmaceuticals with electroactive groups. Advantages are very high sensitivity for the electroactive analyst, excellent for trace level analysis, and applications for the vitamin assays, neurotransmitters, stability studies involving the oxidation type of reactions. Then another one is the ELSD detector, evaporative light scattering detector, ideal for non-volatile compounds, compounds with poor or no UV response like lipids, triglycerides, polymers, sugars and surfactants. So how it works? So the evaporative light scattering detectors works on the principle that mobile phase evaporates, then analyte particles scatter light, and this is measured by the detector. The benefits of ELSD is it works with the gradient illusion and not dependent on the chromophores. Whenever you are going to select the detector, you should understand the chemistry of the analyte and then the method requirement. UV visible organic compounds with UV absorbance, PDA, UV analytes plus peak purity evolution and evaluation. Fluorescence, highly sensitive detection of aromatic and conjugated compounds. RID for sugars and the compounds with which lack the UV absorbance. ECD, electroactive molecules. ELSD, non-volatile, non-UV absorbing compounds. So if you select the right detector, then you will get better sensitivity, fewer interferences, and you will get more reliable results. So this is regarding the HPLC detectors. Thank you for watching the video.